containers. This is what we will sum it up to in the last, but then before we reach here, let's understand what all we need to take care and see in the journey of it. And all of us might be very well aware about one of the aspects, like why we started using containers. We had virtual machines. They were able to give us a lot of libraries, apps, isolations, and everything, which was running on top of the hypervisor. But then since we did not have any of those optimization of resources, there's a lot of memory and CPUs and OS management overhead functionalities being taken care. We came across certain technology which can actually unleash everything that is already running on the host and still be able to run multiple items along with it. And we call them as containers, which started with jailed environment concept and BSD, and then so I talked about this is the end goal where we want to reach, and the next slide to it is talking about, though we all know about what Docker container security is, Docker container is, and why to move from VMs to Docker. Let's go to the next slide, which will talk about this. And here I was talking about that unnecessarily we were investing a lot of our resources on the hypervisor and guest operating systems, resource management, and other overheads, which we in the end ended up merging it and bringing it closer to the layer of the operating system which we are running on right now. And it started from jail concept of sessions and then BSDs, and we ended up with a mature product called as Docker. We have other competitors as Rocket and stuff, which are not so very widely used, but then Docker is one of the most popular one which we are using. And here is the good thing that we have is we can run very optimally with less number of resources and less amount of resources. But it also, if you see, it also kills all the isolation layers that are between the OS and the apps that we run. And it actually sits inside the host operating system, and it is actually sharing a part of the kernel code and directly interacting to the kernel. So that is where it becomes more important for us to understand the containers and how they work and what all needs to be taken care when we are hosting the containers. Yeah, we'll go to the next slide. So first of all, why was Docker required? There are a lot of reasons that we have. One of the most important reason is that it is pretty lightweight. You actually can ship whatever you have built. So whatever you develop goes to the production. There is no more scenario where somebody can say that it is running on my machine, it is not running on the production. So to avoid that, the atomicity of what you need to scale is pretty well defined so that you can scale as many as you want. You can keep on replicating your Docker instance rather than trying to scale a particular module or a library of the application, which makes it pretty easy for you. And whatever you develop, that is what you host, is driving more towards adoption of Docker. And everybody is going towards Docker. It gives you one of the serverless ways to host things, and that is where the tendency is to go more and more, and adoption of Docker is taking up. We'll go to the next slide to understand when we are hosting with Docker. I was asking somebody on one of my previous sessions, and he said we use Docker because it isolates everything, and we are not really concerned about what will happen to my operating system and what all is running on the operating system. I can run my own stuff on Docker and stuff like that. But since we saw on the diagram that it runs very well sandwiched inside the operating system, the isolation is a feature that we need to implement. And if we really need to implement isolation, then how do we achieve that implementation of isolation? And if we do not do that, what does it cost actually? So Linux kernels provide us a feature of C groups, and by using namespaces C groups, we can categorize and we can isolate CPU, memory, PIDs, networks, and all the resources that Linux kernel uses. That way you create two different contexts or n number of different contexts where you want to run things. That is the core of isolation of containers. But if you don't do that, then what happens? Let's have a look at that on the next slide. So, for example, if a machine is running containers, and the containers are having some processes running inside it. Now, for example, if a container is resource heavy, it starts eating up a lot of resources. The other containers on the same machine will end up starving. It can go to the level that even the host is getting short of resources, and then the whole of the application gets impacted. So we really need to understand that there is a scalability which is required, and for the scalability to happen, we need to contain the containers on their own boundaries, on their own limits, right? So we'll take an example to see how do we do that towards the demo part of it. I'll not jump in right now because we got some screen switching problems, so we'll deal with that in a while. So that is one area that we need to understand: resource consumptions and resource limitations. How do we contain a particular instance of container to run within its own defined boundary limits? That's one area. And second, we'll go to the next slide to understand what are the impacts if we really do not. Anjali, can we go to the next one? So if we do not do things properly, when we say do things properly means we need to write something across containers and we end up using a volume, which is basically a shared space, right? So one of those examples is this. But anything which is shared across between the host and the containers, if we do not do those well, we are in a capability that we may end up having access to a whole lot of host resources which we do not want to. So how much we are vulnerable on that side and what is a practice that keeps us away from that is something that we will look into. Next one that we are going to talk about is if there is a vulnerable application deployed, what happens and how we are exposing things. So I have, for this particular piece, I have taken a vulnerable image and I have deployed it, and I'm going to show how you can get into a reverse shell of it. And it was around a cell shock vulnerability that was discovered sometime, and a lot of those applications got exposed to it. The shell of the Linux is available to the end user with certain combinations. We will look into that, and I think we will switch over to the demo parts of it. And I'll start with the